The 2200 milliamp power battery supplies the entire system, and the 8 drive motors, 4 front and 4 rear, provide movement. Meanwhile, the 2 central fans with drone motors generate the suction required to adhere to walls and ceilings. Each drone motor is a 3-phase brushless BLDC type, powered through an electronic speed controller, an ESC. They draw the higher voltage from the LiPo 3S 11.1V and high peak currents of about 20 to 30 amps. In a quadcopter, these ESCs convert the battery's DC into 3 alternating phases to spin the propellers fast enough for ducting. The 3 front IR sensors detect walls for stopping and changing speed. They detect the edge transition when only half of the robot's chassis contacts the new surface, while the other half still overhangs. The IR signals trigger a peak increase in fan speed, so the non-contacting half is cold firmly against the wall before the other one reaches it. Once both halves are fully adherent, the fan speed returns to its nominal level to conserve enough battery power for ducting. The control board provides the necessary PWM outputs to command the ESCs and fast analog or digital inputs to reach IR reflections with microsecond response times. A power level shifter is recommended, and a separate relay or MOSFET array switches the high current battery path to the motors and ESCs under command. Therefore, the drone motors receive their operating current and voltage directly from the 2200 milliamp hour battery via dedicated ESCs, exactly as in a flying quadcopter. The IR sensors modulate the ESC throttle signal to the fans, momentarily increasing suction during edge-to-edge transitions. The result is a reliably climbing robot that never loses grip while crossing vertical surfaces.